based on electromechanical system or mechanical rotation. Here the input is star, output will be theta. Okay, and for that, this will be the electromechanical circuit. So let us let us see of the torque with respect to time. Moment of inertia J1, J2, J2, and your dash Q1, Q2, V3. Spring is as K1, K2. Okay. If the question is asking this, write that differential equations of the mechanical system, or else differential equation of the mechanical rotation system. Then what do you have to do? We have to write for the mechanical rotation system. We have seen a problem, right? And there we have wrote that differential equation. If it is not mentioned, to write the differential equation. If the question is like this, determine torque, voltage, electrical analogous circuit. That's it. You don't need to write a differential equation. Okay. If it just mention determine the differential equation governing the mechanical system, if the question was like that in last class we have seen a problem, right? So if the question was like that, it means you have to write the differential equation. If not, straight away you go to the torque voltage. For that, what do you know from the torque voltage? D square theta by dt is what? D omega by dt. And for d theta by dt is omega, and theta is integral of omega t. So for J1, how will be writing? J1 d square theta by dt square. And okay, this J1 means the equation. What about the equation? What is this equation? J1 d square theta 1 by. So it is equal to what? D omega 1 by dt. So here corrected and visual dashboard, that is V1. So for V1, how will be the differential equation? V1 d theta 1 by dt. Theta by dt is equal to what? Omega. So it is omega 1. Next is the common to be connected string, that is K1. For K1, it will be written as K1 into theta 1. Okay, theta is equal to what? Integral of omega 1 dt. Since it is common, how will be writing? Omega 1 minus omega 2 dt. It is equal to, here is a input P of t. So that is P of t. This is equation number 1. Okay. Next, there is one more, two more moment of inertia. So how many equations will be getting? 3 equations. And for J2, it is J2, say P omega 2 by dt. Clear? So for J2, how will be getting? D square theta 2 by dt square will be getting. So D square theta by dt square will be equal to d omega. So it is 2 by d omega 2. Since here it is omega 1, here it is omega 2, and here it is omega 3. So it is written as omega 2 by dt. And there is an individual dashboard, that is B2 omega 2. Correct? Next, two strips are constant over here. So for K1, we will be writing as K1. How will be writing it? Omega 2 minus omega 1 dt plus another strip K2 as omega 2 minus omega 3 dt is equal to what? 0. And this is equation number 2. Integral. Integral of omega 2 minus omega 3 dt. And next, third equation is J3 d omega 3 by dt plus d3 omega 3 plus K2 omega 3 minus omega 2 dt is equal to 0. This is equation number 3. Now what you have to do? You have to write electromagnetic for voltage. That is, torque means it will be measured voltage V of t. And the moment of inertia J1, J2, J3 is L1, L2, L3. And spring K1, K2 was 1 by C2, 1 by C2, 1 by C3. And as V1, V2, V3 is R1, R2, R3. And that is split omega 1, omega 2, omega 3 is I1, I2, I3. Okay. And now, after you know how the equation will be, then this first equation will become right? L1 d I1 L1
di1
di1 by dt plus
r1
b is r1
i1
I1
plus
plus
1 by c1
1 by C1 integral of
integral of
1 by
i1
C1 integral of
i1
I1
minus
minus I2
i2
into
dt
dt is equal to T of t means
T
equal
of
to what?
t
T of t. Equation number
4
4. And likewise for J2 that is L2
L2
di2
di2
by
by dt
dt plus
r2
R2
i2
into
i2
I2 plus
1 by
1 by
c1
C1 integral of
i2
I2
minus
minus
i1
I1
dt
into dt
plus
plus
1 by c2
C2 integral of
i2 minus i3
I2 minus I3
dt
dt is equal to
0
0. This is equation number 5. And for the third, that is
L3
L3
d
di3
i2
by
dt
dt plus
r3
R3
i3
I3
plus
plus
1 by c3
1 by
c2
so in this case this okay
c2
C2
integral
integral
of
of
i3 minus
I3
i3
into
dt equal to 0
this is equation number
6
6. Okay. Now shall we also celebrate number that is what the input those who are the first function, right? So the first one of function is
d of t
P of t. Okay. So here comes who is individual to P of t?
inductance
Yeah, what that is inductance. Okay. And one more thing is individual to first one that is what? P1, right? P1 is simply resistance R1. So you will notice that it's all in
down
the down section. So you can write it here. Okay. And who is common to both the
k1
K is filled with what?
capacitance
C. So this is L1, this is K1, and this is R2. The current load is I1. And the next that is for L2. The indigenous here resistance R2. Continuous K2, right? K2 is resistance C2. So this is L2 and this is R2. Okay. And one next thing what it is? That is for L3
resistor
1 VV
R3
R3, right? So R3 that is the current load here is
I1
and for here it is
I
I. That's it. This is the circuit diagram we have to draw. That's all about this problem. Okay. If it is asked whether star voltage everything about this, this is the fan voltage everything about this circuit. That's it. The next thing is same. What is the problem for the same mechanical rotation system? Okay. That is we have to determine differential equation, star voltage and the star current. Okay. So first, this is the mechanical system. Okay. First, we want to have to write the differential equation. Problem will be like this. Determine the differential equation coming from the mechanical system and also obtain the torque voltage analogy as well as torque current electrical analysis. The procedure like this, you have to do all the things. Okay. First, differential equation governing the mechanical system. So, what is the differential equation that governing the mechanical system? J1
d square theta
d
by
square theta 1 by
dt square
square
plus
plus
b1
b2 that is what? B2.
b2 b2 ಅದು b2
So this is y1 that is b2. So b2 that is what plus b1. Okay, b1
d theta 1 by
theta 1 by dt
plus
plus
k1
k1 this common to both ways.
theta 2 theta 1 minus theta 2
theta 2
dt
equal to what? We have the symbol that is T of t. That is equation number 1. Clear? Next, the second equation that is J2 d square
dt square
plus
d2
p2
d theta
d theta 2 by
dt
dt
plus
plus
k2
individual, that is k2
theta
theta 2 again
plus
from
k1 theta 2 minus theta 2.
theta 1 is equal to 0. This second equation. This is the differential equation governing the mechanical rotational system. Now what we have to do? We have to do the transforming. Okay, transforming. So on replacing, or effect on replacing. Okay, so on replacing. Okay, in terms of mechanical system, what related system we have to replace it. In place of d square, theta by dt square. That comes the angular velocity. That is what?
d
d omega by
dt
dt. Okay, so theta will be now that is as omega 1, and this will be as
omega 2
omega 2. Okay, yeah. So it is equal to omega, and likewise d theta by dt
omega
omega, and theta is equal to
integral of omega
omega
dt
dt. So now both the equation we have to replace. So it will be like j1 d
d omega
1 by dt plus
d1
d1
d
omega
omega
1, correct?
plus
Next,
k1
plus k1 integral of
omega
1
1 minus omega 2 d
dt is equal to what?
d of t
Okay, where this is equation number
3
3. And next, j2
j2 d omega
d omega 2 by
dt
dt plus v2 omega 2
plus
plus k2
k2
integral of
omega
omega 2
dt
dt plus k1 integral of omega 2 minus omega 1 dt is equal to 0. Equation number 4. Now we have to go for chronological cycle. That is first torque, voltage, and voltage. So if it is transmission, we have to replace it with
E
E
of
of t. So the first equation will be the, if it is J, voltage will be with inductance, dashpot with resistance, spring with capacitance. Okay. So now what happens to the first equation? L1 d omega 1 will become
di1
di1. That is L1 di1 by
dt
dt plus v1 is resistance R1. R1 into I1 plus K1 is
1 by
1 by C1 integral of
I1
I1
minus
minus I2 into
dt
dt is equal to what?
E of
E of t. This is equation number 5. And likewise, we have to write for the fourth equation, that is L2
di2
di2 by dt plus R2 I2 plus
1 by c2
1 by C2 integral of
I2 dt
I2 dt plus 1 by C1 integral of I2 minus I1 into
dt
dt is equal to 0. This is equation number 6.
6.
For this, what we have to draw?
Circuit
We have to draw the circuit diagram. So if this is 6, how will we draw the circuit diagram? The source is what?
E of
Voltage E of t. Okay. So next two concepts is connected
inductance
with the inductance. So we can draw like this. Okay. It is connected with the inductance. Along with the two comes resistance. Resistance. Who is common to both
capacitance
phase capacitance, right?
c1
C1. So it is L1, this is R1,
C1.
and this is C1. The current will be this
I1
I1. This is first. Next two comes V2, right?
inductance L2
R2. Sorry, next J2, that is
L2
L2. Okay. L2. In L2, who is there?
resistance R2
You can draw like this. Okay. Resistance
R2
R2. Next two comes
inductance K
inductance K. This is what? Sorry, it's not inductance. Spring K.
capacitance K
C. That is spring K. Mechanical system.
C.
The string has K2. K2 is written with
C.
so it is now C2. This is the car is electrical autonomous circuit. Now we want to move on to car current. So there we have to consider the same current for the equation and we have to write in terms of current. Okay. So first what happens J moment of inertia. Car will be so J of T. J moment of inertia as capacitance C1 and that's what we are going to as
Resistance.
Conductance. This is the rule of resistance that is conductance and angular this omega as P1 V2 as voltage and next K1 will be equals 1 by the reciprocal of inductance. So how will we write it? J1 as what? C1 V1 by dt. That is the omega is what? V1. So the omega is 1 is V1 so V1 by dt plus what is V? Conductance, right? That is 1 by R. So integral of V1 V2 means
V1 by R.
what it is?
V1 by R.
V1
by R.
by R1. Next, what it is? For K1 it is
1 by
L.
1
by L1. 1 by L1 integral of what it is V1
minus
V2
dt
into dt is equal to what? R. That is the current that is I of t. This is equation number 7. Okay, and the next equation that is
C2 dV2
by
dt
dt plus
V2 by R.
that is V2 by R2, right? 1 by R2 into V2. So V2 by R2 plus
1 by
L1
L2
sorry 1 by L2 integral of V2 dt plus 1 by L1 of integral
V2 minus
V1 into
dt
dt is equal to what? 0. This is equation number 8. For the same, we have to draw the circuit diagram. How will we do it? That is source getting transformed. So what we will do now? This is the current. So that is I of t. Okay. So now, what is junction J1? What is J1 as? Capacitance is directly parallel. Okay. And next two comes the individual resistance R1. Both are known. First node is P1. Okay. And we connecting common to both. That is the K1. Okay. The K1 is what? Inductance. So we have to draw the inductance. That is L1. Next two comes J2. J2 is a
C2
capacitance. That is C2. Okay, next capacitance means division of
resistance
V1 by
R2
R2. Yeah, next who is one more
1 by L.
The result
Inductance.
K2 is what?
Inductance.
Here again. Correct? Okay, so that is C2. This is R2 and this is L2, this is L1, here it is R1 and this is C1. And the voltage here is
V2.
That's it. So the next topic is law of diagram technique. To determine the transfer function, we will be using one more technique that is periodicity block diagram. So in block diagrams, what happens? There is a system. That input and output. That is a way. That is a pictorial representation of a function which is performed in a particular block. That is the block. So here the elements are this block. There is a branch point here and the summing point. These are the three elements of the block diagram. What will be having in the block diagram? Blocks will be there. Branch points will be there. Summing point will be there. So blocks means we know that. That is transfer function g of s with the input and the output. Then branch point. So if we take some number from the this point is said to be branch branch point. Okay, that is in concurrence. Here we can say that A is given to G of us, and A is again given to function some other function to give to the some other system. So concurrent operation to make a system of multiple things we have to take a this point as branch point. Okay, and the summing point. If I have to make arithmetical operation, that is either I have to apply A, here the function is minus means the output will be as A minus B. For that purpose, here we are having a summing point to add up to subtract some of the inputs. Okay, these are the basic elements of a block diagram, and to determine where it is being used to find out the transfer function. Okay, so if we find out transfer function using the block diagram reduction technique, can we make differently? We can't able to do that. There should be certain rules so that everyone can apply the same transfer function, right? So based on that, there are 10 rules of it. So first let me explain the 6 rules of it. That is, for the first rule is combining blocks in cascade, which is in series. Okay, the two blocks is one after the other. G1, G2. It's connected in cascade. Overall, we can write it as G1, G2. A is given to G1, G2 means it can be cascaded like this. Okay, it can be written the whole like this. Okay, and here which means we have combined both the blocks. That's it. Okay, and next one is combining the parallel blocks. If it is connected in cascade, we can combine it like this. Okay, if it is connected in parallel, we have to connect it by using a summing point over here. That is G1 is added to what? G2. So what is the output will be getting? A into G1 plus G2. So we can write the whole as A is given to what? G1 plus G2. So it is A into G1 plus G2. The third is moving the branch point before the block. So here is a branch point over here. If you see A is input given to G, output is AG, and on the branch point we are taking it as AG. If we have to move this branch point over the different segments, what we have to do? Again we have to insert the block AG. Output is what? AG. Here is also a we need output AG, right? So A into G, AG. Here is also A into G, AG. That's it. Likewise, moving the branch point ahead of the block, we have to do that side, which means A is equal to the block AG, will be getting block G will be getting AG, and A is straight away we are getting. Okay, so if it is like this, that is A is given to AG. If we have to move this branch point over the ahead this side, what we have to do? But the output over here is A. What we have to divide it by G, so that AG divided by G will become G cancel. I will be getting A. Okay. Next moving the summing point before the block. If there is a summing point after the block, this is a block. AG is here. AG is here. A is the input to the G. So AG is the output of here. Here is a B as input I am giving. I have to move the summing point over the difference. How are we doing? I am giving as B into 1 by G. So the output will be here as B by G. So here I am giving input as A. Both are already added. It will be like A plus B by G. Now again I am multiplying it on G. So what happens? AG plus B by G getting transferred. AG by C here is also what is output? AG plus B. So both are same, right? So moving the summing point ahead the block. So if it is like this, A added to B. So the output here is A plus B. We are multiplying into G. So how will it be? A plus B into G. If I am doing ahead, what I have to do? I have to do A to G as well as B to G. Okay. Now the summing point is to the ahead of the block. Okay. Now after that, we will add this what will be AG plus B. If I take G common outside, A plus B. Here is also A plus B into A plus B into G. This is the rules, and 4 rules are that I will continue.